Good afternoon, everyone. My name is Abby Fulp.
My name is Maggie McLean.
My name is Marian Gowan.
And we are the roaming Remedies. For the past year, we've been working with the WakeMed Cary Nursing Department to fulfill our mission to increase nurse productivity and efficiency, as well as our vision to develop improvements on existing equipment used in patient care.
All right, so if we could just have a quick raise of hands. How many people actually know what this device is? All right, good. Apparently our posters paid off. This is a pulse oximeter that usually goes on the fingertip. You might have seen it in a doctor's office whenever you go in. They put the little finger clip on your finger, usually gives you a reading in the 90s, hopefully. It tells you how saturated your hemoglobin is with oxygen as it's circulating through your body. Well, little story to tell you about why this is so important. I'm going to introduce you to Granny. Now, Granny is 82 years old, and she has seen medical technology grow up from the herbs in her backyard to cloning and even hip replacements. However, when Granny's home health nurse comes to pay her a visit, there are still issues taking basic vital sign measurements. The finger pulse oximeter given to the home health nurse will not pick up an accurate reading on Granny's poorly circulated fingers. Well, Granny's on oxygen, and now the nurse has no way to tell whether the oxygen tank's actually providing the oxygen it claims, or if it's slowly sending Granny into a state of hypoxemia. If Granny's not treated soon, her lungs will start to fail.
There are observations of nurses with experiences similar to Granny's who determine that nurses need a way to measure oxygen saturation in patients with poor peripheral perfusion. Most common method to measure oxygen saturation is with a finger sensor. However, ear clip sensors and forehead sensors exist, but they malfunction in their method of attachment. The most accurate way to gain a reading is through an arterial blood gas. However, this is both invasive to the patient and time-consuming for the nurse. Our idea is to bring the oxygen saturation measurement closer to the core to eliminate the issues seen with the extremities.
In order to bring the oxygen saturation measurement closer to the core, we developed a Circulox device. In the first half of our device, as you can see around the stethoscope head, the sensors and detectors are on the underside, which comes in contact with the patient. This picks up our initial reading, which is then wirelessly transmitted via Bluetooth to the second half of our device, the external display box. This display box has circuitry that does the post-processing of our signal and would also contain an LCD screen to display the reading. It can be connected to the stethoscope tubing as shown, or it can be removed if the nurse desires.
So moving an oximeter closer to the chest sounds like a great idea, but first we had to prove to ourselves that the finger sensors currently used by home health nurses were in fact affected by poor circulation. But we have three pretty healthy individuals up here. How are we supposed to induce poor circulation? Well, we tied a tourniquet around our wrist and held it above our heart and cut off our circulation. What we noticed was as the blood slowly quit flowing to our fingertips, our oxygen saturation level was dropping. But we know our oxygen saturation did not change in that short time that we applied the tourniquet, so we decided that was pretty good evidence that maybe the oximeter should not be on the extremities, but moved closer to the core where poor circulation wouldn't affect it. So we did some research and patent studies and found out that the University of Ulster had actually developed a technology that was applicable on the chest and could pick up accurate readings. However, whenever we attempted to contact them, we were unsuccessful.
We were also able to obtain a reflectance oximeter from a local vendor. This device actually goes into a standard iPhone and works in taking the oxygen saturation measurement using the patient's thumb. We tried using this device on different areas of our chest and were able to get readings. So this helped us kind of prove that using the current technology, taking oxygen saturation measurements at the core would be possible. We had originally wanted to source our technology from a local pulse oximeter vendor. However, this was both out of our time scale and budget. We started working with a few mentors at our university to develop our own pulse oximeter technology. This consists mainly of two circuit boards, as shown here, that was designed specifically to fit into our oximeter casing. We were able to receive some preliminary data in the form of absorbance and optical density values of the reflected light, which could later be translated into an oxygen saturation reading.
So going forward, we plan to perform clinical study on patients at WakeMed Hospital to compare the measurements taken with our Circulox device to that of the current finger oximeters and arterial blood gases. We also need to continue making adjustments to our electronics in order to make sure we're taking accurate readings, as well as develop our external display box to move from the computer to an LCD screen. Lastly, we like to get continued nurse feedback to keep enhancing the durability and ease of use of our device.
We would like to thank the following people for their help: Andrew, Jimmy, Paula, the Wakeman nurses and bioengineers, Dr. Oster, Steve Calendar, and Robert Splinter.
Just remember that 20% of Americans over the age of 65 have poor circulation to their extremities. 5 to 8 million people will be affected by our Circulox device. Thank you.